Today we are talking about what is called separation of variables. Separation of variables is the next step in the process of working differential equations. Okay. Yesterday I gave you one last example on the intro to differential equations where I asked you to find a particular solution. And I gave you something like dy dt equals 2e to the negative t, and you had to find the equation that it came from. You had to work your way, just an antiderivative. And that was simple because the original problem was an explicit function. It was solved for y. Today we're learning how to take what was done with implicit differentiation and go backwards. Okay, so we're doing implicit differentiation in reverse. I give you a function that had an x and a y all mixed together, and you took the derivative and got an answer. Now today, we're taking that answer and working our way backwards to find the original problem. Now, this lesson is very, very important as far as the AP exam is concerned, and let me tell you why. There have been questions on this topic on every free response for the past several years. Every year, they have one of these. And not only do they have one of these, of the 9 points for one free response question, this process gives you 5 points. So if you can learn how to do this, you can get over 50% of the points for one whole free response question just by doing this process. So it's very, very meaty as far as point counts go for the AP exam. And it's not that hard because it's the same steps every single problem. I don't care how the problem looks to begin with. It always starts the same way. You always do this first, then this, then that, and work your way through. The only thing that's hard is remembering the algebra to clean up the problems. Okay? So today we're going to practice doing these problems. We're going to focus on specifically, we're going to talk in the notes about particular and general solutions. The homework you're going to focus on is just general. So let's do an example. Like I said, I'm going to write in 2 different colors just to kind of keep straight what was the original problem and what the work is. So the problems look like this. dy dx equals negative x over y, and it asks you to find the particular solution. I discovered last year that when I did this, I didn't specify what the directions would say, so kids saw this problem and they didn't know what to do with it. So when it says find the particular solution, your brain should say, oh, I'm supposed to separate the variables and work it out. Now, in order to have a particular solution, I'm going to have to give you more information, and I'll do that in a minute. Okay, so on this first example, I'm going to write out the steps that we decide so you have them to refer back to in the future. Step 1, you are going to separate, as it says, x's and y's. Separate the x's and the y's. Now, that means that when you are done separating them, everything that has an x and everything that has a y in it will be on the other side. And it has to be that way. Now, for what we're going to be doing, cannot have either a dy or a dx in the denominator. So since the dx is currently in the denominator, it has to move. And the way I'm going to move it is to multiply both sides by dx, which moves this right over there. So the first thing you always move is the d, whatever letter, dt, dx, that is in the denominator to the other side. Now we have a designator. The left side is the y side, the right side is the x side. The dy and dx have to both be in the numerator. So that's why they get to stay put. Now everything else moves. All right? So since there's nothing with dy, it's done. What over here needs to move to the other side? How do I move it? Multiply both sides by y. Sometimes you'll divide to move stuff, but sometimes you'll multiply. So in this case, we're going to multiply both sides by y. So now we have y dy equals negative x dx. You have successfully separated the variables. That wasn't so bad. Okay. Step 2, we are going to integrate both sides. Integrate both sides. So that means I just draw an integral symbol on both sides of those problems. Since I have a dy and a dx, that follows suit that that's what I need to do. All right. Are these indefinite or definite integrals? They're indefinite. How do you work an indefinite integral? What do? You take the antiderivative. So what is the antiderivative of y, dy? This is 1/2 y squared. Remember, the power goes up 1, and then you put the reciprocal in the front. Doesn't matter that it's y's, it's just done with a y. As long as this letter matches the d letter, as long as it says y dy, theta d theta, t dt, I don't care, whatever, you do the process the same way. Now, indefinite integrals usually have what at the end? Plus c, but I'm not going to write it, and I'll tell you why in a minute, okay? Right, equals. Now do the other side. What is the other side going to have for an antiderivative? Negative 1/2 x squared plus c. This side gets the plus c. Here's why. Okay? In reality, both sides get a plus c. But as you clean up the problem, you would end up having to move it anyway. So let's pretend for a minute that this side had a plus c value of 7, and the other side had a plus c value of 9. When I move the 7 over here, what's going to happen? This is going to turn into a what? A 2. Agreed? So I don't have a constant over here anymore. I just have a constant right here. Okay? When you do this, I'm going to start calling this what I call the magic C. It is a C that can be any number you want it to be until I start plugging in values. So the C that was here moved over to join the C that was here and just made a brand new C. Does that kind of make sense to you? Okay. So please write under here, only the X gets, quote, the plus C. So you're only going to put it on one side. Usually it's the right problem. That's where the independent variable is. Okay? I want to clean this up just a little bit before I go any farther. And I think it wouldn't be too difficult to get rid of the 1/2. So what should I do to get rid of the 1/2? Multiply both sides by 2. So multiply this by 2 and that by 2. So now I have y squared equals negative x squared. Here's the magic C again. A constant times 2 is just another constant. So we just put plus C, not plus 2c. To get rid of the 1/2, just to make it look a little nicer. Okay? This is now the general solution. We talked about this yesterday. The general solution is when you get to the point where you have the plus C, and it's cleaned up a little bit. Okay. When you're doing the assignment, just look at the answers at the bottom, and that'll tell you when to stop. You could have stopped here. I want it to look a little nicer. I stopped here. Okay? So I found my general solution. Now, in order to find a particular solution, they would have to give you a point, and this point they're going to give you is the point 4, 3. This is how we find the C. We talked about this yesterday as well. So at the point 4, 3, we take our general solution, plug in the values for x and y, solve for C. So 3 squared equals negative 4 squared plus C. 9 equals what? Negative 16. Why is it negative? Because the negative is not squared. Only the 4 is squared. If the negative was squared, it would have to be in a parentheses. So only the 4 is squared, and then you make it negative. So that's negative 16 plus C. So C equals 25. Are you good? Okay, if the question says find the particular solution, that means go back to the general, plug in the 25 for C. Y squared equals negative x squared plus 25. That is a valid answer. You might see the answer a little bit different, i.e. they might move the x squared to the other side, because then it looks like something you've seen before. If you move the x squared over, you're going to have x squared plus y squared equals 25. And what kind of equation is that? That's a circle. So here is the particular solution. Either one of those is valid. On a free response, they don't care where you stop unless they tell you specifically what to do, and I'll talk about that in a minute. But if it's just asking for a general particular solution, it could be either one of those. All right? Any questions about what I did? And like I said, the steps are the same every time. Separate the variables, integrate both sides, find your C. Are we good? All right, let's do another one. dy dx equals e to the x minus y. And I'm going to scooch over a little bit and write at the point 0, 2. I'm going to write it right there in the problem. So this one is asking for the particular solution as well. You will know for a fact that it's a particular solution when they give you a point. If they don't give you a point, you can't find C. All right. Step 1 is to do what? Separate the variables. But I got a problem. I've got both my x and y trapped in the power up the e. And your brain first thing says to do, what do you think? Natural log sounds like a good choice. The only problem is you cannot take the natural log of a dy dx. That's not mathematically allowed. So that's kind of stuck. So what we're going to do is something that we don't usually do with a problem, but in this case we have to. I want you to think for a minute, when you see a problem where the exponents have been subtracted, what did it look like before it was worked? It looked like division, right? Doesn't division tell you to subtract the exponents? Right? So let's undo this problem. It would be, how would it look? E to the x over e to the y. So it's kind of like I did the problem backwards. It's like taking an answer of 5 and writing it as 3 plus 2. Sometimes we need to do that. So now I am able to separate the x from the y. Are you following what I'm doing? Okay, so let's do that. When you separate variables, what's the first thing you always move? The bottom right here. That has to move every time first. So dx moves over there. The d of the denominator moves first every time. It moves to the other side. Because like I said, the dy and the d whatever have to be both on top. Okay, now, what's on the wrong side? E to the y. How do I move it? Multiply. So we're going to multiply it over here, like so. Are we good? So now we have e to the y dy equals e to the x dx. Separated variables. Oh, I forgot to talk about that. I'll go back and do it in a minute. Okay, what's step 2? Integrate both sides. Integral, integral. I'll do it on this problem. Okay, so what is the antiderivative of e to the y dy? It's a copy-paste problem, isn't it? Think about it. Derivative and integral of e to the y are copy-paste. So e to the y, remember plus c is saved for the other side, equals what? E to the x plus c. Are we good with that? Okay, here is our general solution. But now we're going to take and find the particular solution with this 0, 2 over here. So plug in 2 for y, 0 for x. E squared equals e to the 0 plus c. Do we know what e squared is exactly? No. So just leave it as e squared because we don't have a calculator. But you do know what e to the 0 is. What is that? It is 1 plus c. E equals e squared minus 1. Are you okay with that? Now go back to here and write e to the y equals e to the x plus e squared minus 1. Okay, that is a valid particular solution because the c is gone. But very recently on the AP exam they have started writing this. Find the particular solution y equals f of x, close quotes. If you see that phrase, that means you have to solve for y. give you the point for getting the equation unless you do. Okay, so if you see this phrase, that means you have to keep going from here. You're not done yet. Does that make sense? Because when it says y equals f of x, that means your answer has to be a y equals something. So my question is, how do I get the e's off the y's? That's natural log. So we are going to natural log both sides. Now be careful. When you take the natural log, you cannot natural log individual terms. You have to natural log the entire side. You can't say ln of e to the x plus ln of e squared minus ln of 1. You can't do that. It has to be ln of the whole thing. Okay? What is the natural log of e to the y? That is y. If these things in here will then break it apart into ln of this plus ln of that plus ln of that. But they're added. And so I can't. That is done. That's as far as you can go with this side. So ln of e to the x plus e squared minus 1, that is your particular solution. Because I solved for y. Yes, sir? Because the only way you're allowed to break up ln's is if the inside is multiplied or divided. If the inside is added, you can't. You're not allowed to. It doesn't mathematically work. Okay? All right. Let me show you real quickly where the points come on an AP question for this. Okay? You get your first set of points for separating the variables correctly. If you can separate the variables, and that's all you can do, you get a point for that. You then get a point for taking the antiderivative of both sides correctly. And here's the good news. You get a point for just remembering to write plus c. Even if you totally screwed up your antiderivative, if you wrote plus c, you got a point for that. And that's the way I'm going to grade it when I grade these problems. Okay? You get a fourth point for finding c correctly. And then you get your fifth point for writing the equation. And that's what I was talking about. If they say y equals f of x, if you don't solve for y, you don't get this last point. Even if that one is correct up there. Yes, sir?
So you said even if we messed up our integrals, if we add a plus c, then it's fine. But we get a point for it.
Mm-hmm.
But for the next step, if we just plug into the messed up integral and we find c, but it's not c.
You still get the point for that too. Yes. So let's say you messed up the antiderivative here. You said ln of y equals ln of x plus c or something like that. Okay? If you took this point and plugged it into your wrong equation correctly, you get the point for the c. And then you get the point for the equation too. Yes?
So in the last equation, if it was multiplied, like it was ln of e to the x times e squared times 1, would you have to keep going further?
You would not have to, no. You would not. Now, the reason you might want to is, let's say this was a multiple choice question. You would have to know that your answer and that multiple choice question were the same. Okay? Good question. All right. Now, let me say one more thing, because I really want this to be recorded. If you solved for c after you ln'd both sides, okay, your c would look a little bit different. And that's something I want to say. Let's say you and a friend were working on this problem together. You decided to solve for c right here. They decided to clean it up more and then solve for c. Your c values might come out different, but in the end, your equations should be exactly the same. Okay? So just because you're working with somebody and you get two different c values, that's not necessarily wrong. Just look at your final answers. If the final answers come out the same, then you're good. Does that make sense to you? Because it has to do with how far you've gone in the problem as to what your c is going to look like. Okay? Any more questions? I have one more example to do today, and it's a little bit unusual, so I want to go ahead and work through it. But it's going to turn into something I think you might have seen before. So I need to go to a new sheet of paper. Example. dy dt equals k times y, and I want the general solution this time. The homework that you're focusing on today is general solutions only. Tomorrow you're going to do particulars. But I wanted to go ahead and put particulars into the notes because general is on the way. K times y. K is a constant. All right. Step 1 is separate the variables. So I need to move what first? dt. So mark out dt, put it over there. Okay. K, being a constant, can go on either side with y or with t. But if I move k over with y, where's it going to be when I move it? In the denominator. I would really rather not have constants in the denominator. I'd rather have them in the numerator. So for ease of working, k is better off left right here. But y definitely has to move. How do I move y to the other side? Divide by y. So this is the first time we've had to divide to move something over. So mark those out. So I now have dy over y equals k dt. You've separated the variables. What's the next step? Integrate both sides. Integrate, integrate. Okay. Haven't had one of these today. What does dy over y integrate to be? ln. That is an ln problem. So ln, absolute value of y, equals. Okay, now we get a little weird. Okay. Some of you already know what it is, but let me explain it to the rest of you. K being a constant, can it come out of the integral? Yes, constants can move in and out at will. That was something we learned in the properties. So k, just write down k. K's out of the integral. If I move k outside, what number is still in there? A 1. So what's the antiderivative of a 1? An x, right? But it says dt, so we don't use x's, we use t's. So instead of saying x, we're going to say t. So it's kt. And don't forget the what? Plus c, because that's a point right there. All right, do I need to say the k thing one more time? Y'all got it? All right. Okay. It says a general solution, but I want y by itself in this case, because I want to turn it into something that I'm familiar with. Do you know how to of a y? We're going to raise it to the power of e. This was something those of you who took pre-AP pre-cal learned last year. If you took regular, you may not have seen it. But you raise both sides to the power of e. Now remember, it has to be the whole side. Very important that you do it this way. Now we're going to do some unusual math in a minute, so stay with me. Okay, e to any power is always a what kind of answer? Positive or negative, do you think? It's always positive because e is like 2.7. So that to that is a positive power, so e to the ln of the absolute value of y is just y, because it's always positive. Equals. Now, c being here is a problem. I want to clean it. It's not clean when it's really... Now, I want you to think back to the problem we just did. When this problem had e with these two powers, we turned it into division. If we have e with two powers that are added, what do we turn it into? Multiplication. So I want you to write e to the kt times e to the c. Now, e is about 2.7, and if I raise 2.7 to a constant power, do I get another constant? Yes. So you mark that out, make a big fat C out of it. E to a constant is just another constant, and this constant, instead of being added to this, is now multiplied to this. So your answer is y equals c times e to the kt power. And there is your general solution. Okay. Does that equation look kind of familiar, like from pre-cal? You ever remember what it's for? Okay, this letter C was not a C in your book. Do you remember what it was? It was an N, because some teachers called it the Neckett equation, right? The Neckett equation? Okay, it was like N equals N sub 0 e to the kt. This is exponential growth and decay. This is the biggest application of differential equations. So next week, we're going to be learning how to do exponential growth and decay problems. This formula was born out of this differential equation. The rate of change of y is proportional to y. That's what that equation is talking about. We'll talk more about that next week. But that equation gave light to this equation, which talks all about exponential growth and decay. Are there any questions about what I did? This process right here, going from here to here, or actually these last 3 steps, big on the AP exam. Just be comfortable with that. And you're going to do it several times, so it'll just become second nature. Okay? Here we go. All right. The last example is as follows. It's kind of long. This mimics the hardest question on that worksheet that you have. Here's what it looks like. Y, parentheses, 3 plus x squared, y prime minus x, parentheses, 2 plus y squared, close parentheses, equals 0. That looks a lot longer than anything I've done so far. Oh, yeah. Okay. Several of you got quite a ways through the worksheet yesterday, and that was great, but I failed to mention something that I'm definitely going to mention now. If your differential equation has y prime instead of dy dx, you must change it to dy dx so you can separate the y from the x. So this one not only needs to be changed to dy dx, I also have a minus sign here. And that means I need to move this whole term over to the other side because they have to be separated by the equal sign. So I'm going to change this to dy dx and move that over all at the same time. So y, parentheses, 3 plus x squared dy dx equals x, parentheses, 2 plus y squared. Didn't write that the way I wanted to, but that's okay. All right, now I'm going to change colors to show work. I said just a minute ago, and I'm going to repeat it again, whatever D is on the bottom has to move. I don't care what's on this side. If this side was all Y's, I don't care. It has to be the X's over there. So move the DX right over there. All right. So what's on the wrong side over here?
X squared.
The 3 plus x squared is all one unit, so I have to move it all at once. How do I move it? Multiply or divide? Divide. So I'm going to draw the fraction bar. 3 plus x squared. Same thing here. 3 plus x squared. Okay, those two cross out. So 3 plus x squared has moved over. Okay, what about the other side? What needs to move? 2 plus y squared, and it needs to be divided also. So 2 plus y squared, 2 plus y squared, 2 plus y squared on that side cancel. So now on the left side, I am left with y over 2 plus y squared dy equals x over 3 plus x squared dx. Okay, I have now successfully separated the variables. X's are together, y's are together. What is step 2 in the process? Integration. So we put an integral sign right there and an integral sign right there.
Ms. Bell?
Yes?
Why didn't the dy and the dx go on the numerator?
They could. I just happened to write them out to the side. That's a good question. dy and the dx could go in the numerator. They could go out to the side. It does not matter. All right. Now, how do I do this? Okay. One of the things that we haven't talked a whole lot about yet is when do you have to do use substitution and when do you not? Because I gave you a whole worksheet of here's a use substitution. You're definitely going to do it. But now we're in the situation of do I need it or do I not? Okay. This right here, this whole denominator has a power of 1. Do you agree with me? Okay, the whole denominator has a power of 1. And if the denominator on the bottom is a 1, it's probably going to be an ln problem. Okay? But if the denominator is more than just a single y or a single x, you have to do a use substitution. So if you're given a fraction in your integral and the power on the bottom is a 1, and it's more than just a y or an x, you've got to do a use substitution. So I'm going to do a use substitution to this side, and I'm going to work it all the way through before I even look at the other side. Okay? So now I'm going to change colors, and I need to do my use substitution. So u here would be the denominator, 2 plus y squared. What is du? 2y dy. Okay, 2y dy. I have my dy, I have my y, so I need to put a 2 in. And what do I do? What else do I need to do? 1/2 outside. Very good. 1/2 right there. So all of this is du. So when I rewrite it, it's going to be 1/2 integral du on top and u on the bottom. Agreed? What is the antiderivative of du over u? ln, absolute value of u. Now remember, this side does not get the plus c, the other side does. And now I'm going to switch back to x's, so this will be 1/2 ln. Actually, I'm not switching back to x's, I'm switching back to y's, because this side was in terms of y. So absolute value of 2 plus y squared. And that side is finished. Putting my equal sign, saying I'm done. All right, that side's done. Look at this one. Am I going to need a u substitution on the other side too? Yes. So right now, go ahead and do the other side with a u substitution. And stop when you get to the equation, just like I did on this side. Okay, when you're done, look up here and see if you got what I got. Do I have any questions? Yes, ma'am. Because there really is a plus c on both sides in reality, but when I have to go and clean it up, I would move the one on the left side over to the right side and add it together, which would just create a new c. So instead of writing 2 off the bat, we just write the one on the one side, because they would be combined anyway. Okay? All right. Now, I have a general solution, but I want to clean it up just a little bit more. Okay? So, what do you suggest we do first? I see some ln's there, and some of you may be thinking, oh, we need to do the e thing. And yes, we do. However, the 1/2 is in the way. You cannot do the e thing until it's just a plain ln over here. How do I get rid of the 1/2? Multiply by 2. That must be done first. So that would be the natural log of 2 plus y squared equals the natural log of 3 plus x squared plus 2 times a constant is just another constant, so we just write another c again. Some textbooks will put that as C1 and this will be C2, and then the next time you change it, it's C3. I don't see the point because it's just another constant. It doesn't really matter. Okay? Now, if I wanted to remove the ln's, yesterday we talked about how we make this powers of e. So when you put the e on, please put the entire side of the problem into a parentheses to remind yourself that that whole thing is the exponent. How does the left side of this problem clean up? It is 2 plus y squared. Now, on the video, this is going to be all one video, but in reality, it's 2 days apart. Does anybody remember why I'm allowed to take off the absolute value bars again? Young, tell me.
Because, like, e to whatever power is always going to be positive.
E to whatever power is always going to be positive, and when you raise something to a squared power and you add 2 to it, it's still positive, isn't it? Does that make sense? So this whole side is positive. Equals. Now, I can't do that here because of the plus c. And so what we're going to do is what we did on the previous problem. When exponents are added, how did the problem look originally? Was it multiplication or division? It was multiplication. So we're going to write e to the ln absolute value of 3 plus x squared times e to the c. And this is how we get the c out of the exponent. C, we don't like c in the exponent. It's not a good place for it to be. Now, e being a number, 2.7-ish, to a constant power is just a whole new constant. So mark it out, put a big C. And since the c is multiplied to this, we're going to move it in the front. So now we have 2 plus y squared equals c times what? 3 plus x squared without absolute value bars. And now that is the prettier general solution. As soon as we integrate both sides, we really are at a general solution, but they usually want them to look more like this. And actually, probably what they would want you to do is to get the y squared by itself. But that's okay. Now, we're going to go a step farther. We're going to go ahead and do a particular solution because I need to make a point on this problem. We're going to say at the point 0, comma, the square root of 5. I want to find the particular solution. So I'm going to kind of put a big star here because that's where I'm starting the second part of this. The top of the worksheet that you were given is these kinds of problems. Not this hard, but you stop as soon as you find what C is. Then the bottom of the worksheet wants you to go farther. They want you to find the C and then solve it out. So now we're going to take this equation. 0 becomes x, square root of 5 becomes y, solve for C. So 2 plus the square root of 5 squared equals C times 3 plus 0 squared. Once you start plugging in values, C can no longer absorb anything. You are actually trying to find C. I can't say C times 3 is just another C. I can't do that. Not anymore. So this side is going to be 7 equals 3C. So C equals 7/3. So now we're to the point of having 2 plus y squared equals 7/3 parentheses 3 plus x squared. That is a particular solution. Okay, but I'm going to do like the AP tests have been doing, and I want you to go farther. If they say find a particular solution of x, you have to keep going. In other words, you got to solve for y. If they specify y equals f of x, and every test for the last several years has done that, they want you to solve it for y. The homework doesn't necessarily want you to do that, but we need to practice it because the AP does. So take the equation you just found, solve for y. What do? Subtract the 2. So y squared equals. Now, you have the option. You can distribute the 7/3, or you can leave it factored. What do you want to do? Leave it? Let's leave it alone. 7/3 parentheses 3 plus x squared minus 2. You can just leave it like that. They don't care about simplifying. Now what? Square root both sides. Y equals, what are you supposed to put on your answer when you square root both sides? Plus or minus the square root of 7/3 parentheses 3 plus x squared minus 2. That looks great. Okay, but guess what? This is the one time you got to be really careful. This is y equals, but is this side a function? The answer is no, it is not. Because anytime you have a plus or minus on a radical, the top part of the radical looks like this somehow, and the bottom side of the radical looks like that, and that's not a function because it wouldn't pass the vertical line test. So this is not a function. So I have to pick which one I want to use. Okay, so write yourself a note. You must choose plus or minus. You must choose which one you want. This only occurs when it's a plus or minus situation. Well, how do I choose? Out of a hat? No. The way you choose is based on what your point is. Okay? Which equation, if I plugged in a 0 for x, would I get a positive square root of 5 as an answer? The positive square root. Since this is positive, I want the positive one. Does that make sense? Okay. So, write this down. Since f of 0 equals the positive square root of 5, and the square root of 5 is greater than 0, comma, you must choose the positive square root. Notice I'm abbreviating. You must choose the positive square root. So your final, I definitely am done answer is y equals the square root of 7/3 times 3 plus x squared minus 2. That's done. Do you understand why I had to choose? Number one, why did I have to choose an answer? Because it's not a function unless I do. And number two, why I chose the positive one. Do you understand both of those? Do you have any questions?